Hi everyone, in this video let's see box plot. So in the previous 3 to 4 videos we have discussed different kind of plots like bar plot, histogram, pie plot. The idea of plotting those is to visualize the data. Even here box plot will be helpful to visualize the data. Let's see how it will be useful and let's see all the details of this box plot. I'll just make you understand in depth of this box plot. So let's go into the video. It's also a plot which will be useful to visualize the data. Since it is in the form of box, it is called as box plot. So when we have the data in the form of bars, we call it as bar chart. And similarly, when we have the plot in the form of box, so it's called as box plot. You can see the image here. So this is the box plot. This is how the box plot looks like, and you can see the components in the box plot, like the minimum value or the maximum value. You can see some complex terms like interquartile range and upper quartile, lower quartile, and whisker. We have some kind of new terms. Let's discuss those terms as well. So if you can see this picture here, so when you have the data, when you plot that data using box plot, you will have minimum value in the data and as well as the maximum value. So these two represent that minimum and maximum, and this median, right? So when you have the data, you will have the median. So that's the median here. Median is the middle value in that data. We all know this minimum, maximum and median, but the new terms for us is the lower quartile, upper quartile and interquartile range. So lower quartile is this point Q1 here. So this is the place where the lower 25% of the data falls into. And if you can see the upper quartile, above this upper quartile range, we have the upper 25% of the data, right? So that's this upper quartile and lower quartile. And remaining, like if you have 100% of the data, the 25% goes to lower quartile and 25% goes to upper quartile. Remaining, we have this 50% data, right? So that's the interquartile range. So that's where this 50% of the data lies. So these are the terms, right? So it looks complex now, but let's understand with an example. So let's take marks of a particular student in a semester. So let's take in the form of a list. Marks is equal to so these are the 7 subject marks of a particular student. I've just taken for an example here. So when you're just plotting box plot, the first thing what you have to do is you should arrange the data in ascending order. So here you can see the marks are in a random order. So let's make this as an ascending order. So I've just used marks dot sort of, and so you can see now that our data is in ascending order. This is the first step you have to do while you are plotting a box plot. And next you have to compute the median. So median is the middle value. So this here we have odd number of values. So we can easily find the middle value, right? We can just remove these 3 and the upper 3, and the middle value is 78, right? So this is the median value. So let's make it as median is equal to 78. And next thing is we should find upper quartile and lower quartile, that is this Q1 and Q3. So if you want to find the Q1 and Q3, what you have to do is just take all the values before this median value. So before this median value, we just have 3 values, 21, 60, 65. So take all these value and find median of these 3 values, right? So that's Q1. And similarly, just take the median for the values above this median, the actual median, the 78. So this is called as upper quartile. So that's how you just want to find the Q1 and Q3. So since our data have odd number of values, it's easy to find. And when you have even number of values, so we just want to, we know, right? When you want to find the median, we can just take the average of the middle 2 values. So that's how you just find the median. So yeah, now let's find the Q1. Q1 is equal to, so what's the median of these 3 values? So 60. So let's take it as 60, right? And similarly, the median of above three values. So we have this 86, 89, 92. The median is 89. So yeah, so this is the Q1 and Q2. So this is Q3, quartile 3, and here interquartile range is equal to Q3 minus Q1. So this is the interquartile range. And when I just print this, so this is the 29. So this we just got all these values, right? Like median, Q1, Q3, IQR. So what's the use of getting these values? So when you just plot the data, when you just plot the box plot, if you just want to understand the data, so like whether the data is normally distributed or whether the data is right skewed, or whether the data is left skewed. So we can able to find all these things using this box plot. So here in this diagram we have the median at the middle. So then we can just understand that this data is normally distributed. If the data is not, like if this median, like if this line is not present in the middle, whether it is in the right side or left side, based on that we used to decide whether the data is right skewed or left skewed. And also based on this whisker, right, we have this whisker, the length between this Q3 to the max and the Q1 to this minimum value. This is called as whisker. So even through the length of the whisker we can able to find whether the data is normally distributed or skewed. So that's this box plot. And this is how you just want to plot, right? When you have the data, this is how, when you just give a data to a Matplotlib function, right, that is the box plot function. So this is how it computes the box plot. Even you can just able to find the outliers. So outliers are the terms which can be a lowermost value, which can be an uppermost value. Outliers are the data which are not useful at all. So yeah, it can be due to mismatch in the data, right? So yeah, even you can just find the outliers through this interquartile range. So how we can just do is, we have some particular formula for that. So lower limit, right? Lower limit is equal to Q1 minus 1.5 into IQR. So this is the lower limit. So if any data is less than this lower limit, it can be considered as outlier. And similarly for upper limit, Q3 plus 1.5 IQR. So if any data falls above this upper limit, so it can be considered as an outlier. So when you have outliers, so when you just give that data to model to train, then the model won't be in generalized form. So we will just discuss. I don't want to go in depth of this, but yeah, just understand that when you have outliers, the model won't learn perfectly. It won't help the model to generalize the data. Yeah, that's this outlier. And even through this box plot, you can able to find these outliers. So yeah, now let's try to plot the data using Matplotlib. So for that I have already imported the Matplotlib function. So yeah, now let's try to call this box plot function to visualize the data. Let's use plt dot box plot of, and let's give this, right, let's give this list marks. Now you can see the data here, the box plot here. So let's plot this as horizontal. Now it's vertical format. So when I just vertical is equal to false, now you can see our data is in horizontal format. Here you can see the median is not in the center. So definitely the data will be, it can be of right skewed or left skewed based on the length of the whisker, or it can be based on the line of the median, right? Whether this median is in right or left, we can able to find whether the data is skewed or not. So you can see the median is closer to the right side. So from that we can understand this, it is negatively skewed. And when the median line is when it is closer to the left side, when it is closer to the left hand side, so from that we can understand when it is positively skewed. So you can see here like how the positive and negative skewed data will look like, right? So and also you can see the outlier, right? So this point here, so this point which is present here is representing the outlier. I just said you, right, when the point is less than this lower limit or greater than this upper limit, it considered as outlier. So you can see in this data, entire data, all the data is around 60, 65, 78, 86, 89 and 92, but only one data is around 21. So that's why it is considered as an outlier. So like when you're just giving data to the model, the data should be in a normalized form, and also it should not contain any outliers. So yeah, so since here we have you can see here we just have 21 which is an outlier in the sense it happens only in rare situations, it won't occur frequently, so that's the outlier. So we can't able to make our model biased to that outlier. So that's why when we're just giving the data to the model, we will just remove the outlier. So yeah, you can see the point here which represents the outlier. So this is how you plot the box plot. And if you want to compare two data, and like if you want to compare marks of two students, so you can just plot the box plot for two students and you can just compare like whether the data is normally distributed. So if the data is normally distributed, so we can able to understand that a student is performing good in all the subjects. If a data is normal, it's rightly skewed or left skewed, we can able to understand that he is lagging in one particular subject or he is performing good at one particular subject. So yeah, these kind of intuitions we can able to gain through this box plot. So you can see I just used only few arguments here, and similarly if you want to change, we like if you can able to change the width of the box plot. So there are a lot of arguments, but we don't need to use that as all those things. So if you just want to use, you can just go through the arguments present in the box plot and you can just use that. But mostly, yeah, like it's enough, right? Like we are just plotting the box plot, and if you just want to change the width or something, you can just change that. So this is the box plot. This is how you just plot the box plot, and this is the underlying concept behind the box plot. So the median, lower quartile, upper quartile, interquartile, these are all the things present in this box plot. So I hope you understood this video. So yeah, if you feel this video is helpful, and share it with your friends whom you feel this video is helpful, and like the video. And if you haven't already subscribed to the channel, please subscribe, and thanks for watching.